Good morning. Now, today we are going to discuss about purification or refining of metals. Metals obtained by reducing processes still contain some objectionable impurities and have to be refined. Refining technique is used. First method of refining is liquefaction process. This process is used for the purification of the metal, which itself is fusible, but the impurities present in it are not. Means the impurities are infusible. In other words, we can say that the melting point of the metal to be purified should be lower than of the each of the impurities associated with the metal. This process is used for the purification of Asen and Zagan and for removing Pb from Zagan Ag alloy, which is obtained at the end of Parkes process and contains Pb as impurity. Now, second method is distillation process. This process is used to purify those metals which themselves are volatile and the impurities in them are non-volatile. Zagan, Cd and Hg are purified by this process. Now, third process, zone refining method. Zone refining process. This process is used when metals are required in very high purity for a specific application. For example, pure Si and Ge, silicon and germanium are used in semiconductors and hence are purified by this method. Zone refining method is based on the principle that an impure molten metal on gradual cooling with deposit crystals of the pure metal, while the impurities will be left in the remaining part of the molten metal. Now, fourth method, chromatographic method. This method is based on the principle that different components of a mixture are differently adsorbed on an adsorbent. The mixture is put in a liquid and gaseous medium which is moved through the absorbent. Different components are adsorbed at different levels on the column. Later, the adsorbed components are removed by using suitable solvent. Fifth method is electrolytic refining. Some metals such as Cu, copper, Ni, nickel and Al, aluminum are refined electrolytically. The Hoops process is the process for the electrolytic refining of aluminum. Impure aluminum forms the anode and the pure aluminum forms the cathode. In Hooper's cell, which contains three liquid layers, the bottom layer is molten impure aluminum. The middle is the fused salt layer containing aluminum fluoride, and the top layer is pure aluminum. At the anode, means bottom layer, aluminum passes with the solution as aluminum ion Al plus 3, and at the cathode, means top layer, these ions are reduced to pure metal. In operation, molten metal is added to the bottom of the cell and the pure aluminum is drawn off. Aluminum obtained is 99.98% pure. The reactions at anode Al is equal to Al plus 3 electron, and at cathode aluminum ion plus 3 electron gives aluminum. Now, sixth method, vapor phase refining. In this method, the metal is converted into its volatile compound and then collected. It is then heated so that it gets decomposed to give pure metal. So, two requirements are essential for vapor phase refining. First, the metal should form a volatile compound with an available reagent, and second, the volatile compound should be easily decomposable so that the recovery is easy. Now, next topic is extraction of iron from its oxide. After concentration, calcination or roasting is carried out to remove water. Then these are mixed with limestone and coke and put into blast furnace. Oxide is reduced to the metal at 500 to 800 degrees Celsius. Fe2O3 is reduced to Fe3O4 and FeO, and at 900 to 1500 degrees Celsius, FeO plus Cu gives Fe plus CO2, and after reaction of FeO plus C, Fe is obtained in solid form or in liquid form. The iron obtained from blast furnace contains 4% of carbon with impurities of sulfur, phosphorus, silicon, manganese. This is known as pig iron. And iron, which is obtained after melting the pig iron with scrap iron and coke using hot air blast, is known as cast iron. And iron obtained from cast iron by oxidizing impurities in reverberatory furnace with hematite is called wrought iron, means purest iron. Now, uses of some metals like aluminum. So, uses of aluminum are: aluminum is used in as wrapper for food material. Second, in paints and lacquers. Being highly reactive, aluminum is used in extraction of chromium and manganese from their oxide. And fourth, in electrical wires as electricity conductors. Now, uses of copper. Copper is used for making wires and in water and steam pipes. In several alloys, as for example, brass, bronze, and coinage alloy. Next metal, zinc is used in galvanized iron in batteries, in any alloys like brass and German silver. Zinc dust is used as reducing agent in dye stuff and paints. Now, uses of cast iron. Cast iron is used for stove, railway sleepers, gutter and water pipes, toys, and manufacturing of wrought iron, and also manufacturing of steel, which are used in making anchors, wires, bolts, chains, and agricultural equipments, automobiles, plane parts, and pendulum, and also measuring tape also. So these are uses of metals.